Let me introduce you to the interface of Kontur Atlas by demonstrating how to create a multi-criteria decision analysis. First, click the MCDA button and fill in the analysis name field as Test Analysis. For this example, we'll start by picking just one layer, Population. Let's zoom into Europe and see what we have. Our test analysis now includes only the population layer. You'll notice that areas with zero population are marked in green, while areas with high population density are marked in red. You can reverse this and immediately see the changes on the map. For example, large cities like Berlin and others will turn green. Now let's switch it back and explore other features. Each criterion, such as population, has a value range. By default, the minimum and maximum values are set globally, but you can customize them. For instance, you can set the minimum to 200 people per square kilometer. Let's save our changes. You'll notice that the map becomes much greener as many hexagons represent areas with fewer than 200 people per square kilometer. You can also hide values outside your selected range for more focused analysis. If you have multiple criteria, you can adjust their relative importance by assigning weights to each. Additionally, you can control transformations applied to the data. For example, in the population layer, the best transformation is logarithmic. Without this transformation, the map looks flatter, and certain features like the Alps disappear, with most of the map turning green. Let's switch the transformation back on to recover that lost detail. Now let's focus on Switzerland. Here you can clearly see the Alps again, showing how the transformation makes the analysis more informative. Next, let's add another layer to our analysis. Click the Edit button. Let's add elevation as a second criterion. Now the map changes color, reflecting the average of both population and elevation. For example, in one area we see 0.5 for population and 0.7 for elevation. It's helpful to read the legend, as red hexagons indicate areas where many people live high in the mountains. Now let's define the purpose of our analysis. Suppose we want to find areas where the population is at risk of sea level rise, specifically those with elevations under 70 meters. We'll set the elevation maximum to 70 meters and the minimum to 0. Currently, the middle of Italy is incorrectly marked in red because we need to adjust the sentiment. Once we do that, the analysis accurately shows the areas at risk. As we zoom in, you'll notice areas with no population that are above our maximum elevation, which we can exclude from the analysis. To do this, set the outlier behavior to hide. Now the map clearly shows areas at risk of flooding. You can zoom out to explore other regions as well. One last trick I want to show you. You can set the weight of the elevation layer to 0. This allows you to ignore elevation and focus solely on population. In this case, whether the elevation is 20 meters or 50 meters, every person in the area is considered at risk. By excluding the elevation weight, you'll only see the population score in your final result. So as you've seen, we created a test analysis in just a few steps. This kind of analysis can help you easily identify areas at risk or solve other spatial problems like site selection or market analysis.